In Python, we have another data type, sets, which are a collection of unordered elements. These elements are not ordered, and that's why they cannot be indexed like list or tuples. Sets are mutable data structures. We can add or remove any element in the sets. If you are familiar with set theory operations from your high school mathematics, then you can perform those kinds of operations on these set objects. We can create a set using curly braces, or we can also use set function for that. If we want to create empty set, then we must use set function. If I check the data type of this, then it returns class set. If I want to create a set of numbers, then I can create it like this. Again, I can check the data type of this set and I can print the set. If you print them, you can see that it uses these curly braces for set objects. Similar to list function or tuple function, we can pass an iterable into set function and it will create a set out of that iterable. Here I am passing range object with 5 values 0 to 4 and it converts it into a set. As I mentioned earlier, sets are unordered collection. That means we cannot index them. If I try to get an element based on specific index, then it will throw a type error. Set object is not subscriptable. We can add an element into existing set using add methods. Here I have this number set with values 1, 2 and 3. If I write numbers.add and I want to add 4 into this set, if I check our number set, then it now has this 4th item. We can also remove an element from existing set using remove method. If I write numbers.remove and I pass 4 into it, then it will remove this element with value 4. The important attribute of sets is that it cannot have duplicates. Here, for example, I have this colors set with elements black, white and blue. If I try to add red color into it, then that works fine. But if I try to add white into it, then it doesn't add another white element into this set. We already have this white element, so it will not add another duplicate of this. Also here, you can notice that even though I add red after the blue element, there is no inherent ordering with these elements. You can see that it prints red at the beginning. In your case, it can print differently, but there is no specific ordering associated with set elements. Now we can perform different set operations on these Python sets. If we have two sets, set 1 with values 1 to 5 and set 2 with elements 4 to 7, if I check the union of these two sets, then it will include all the elements from both these sets. So here in the union operation, we get elements 1 to 7. The same union operation can be performed using pipe symbol. If I want to find the intersection between two sets, intersection means all the common elements between the two sets, then I can get them using intersection method. Here we have this 4 and 5 which are available in set 1 and set 2. So if I check the intersection of these two sets, then it returns this set with elements 4 and 5. I can perform the same intersection operation using ampersand symbol. If we want to get only the elements which are available in one set but not in the other set, then we can use the difference operation. If I perform set 1 dot difference of set 2, then it will get all the elements that are available in set 1 but not in set 2. In this case, I have this 1, 2 and 3 which are present in set 1 but not in set 2. So it returns a new set with elements 1, 2 and 3. I can perform the same operation using minus symbol. If I want to find all the elements which are not common between these two sets, for example, there are 1, 2, 3 in set 1 which are not available in set 2, and there are elements 6 and 7 which are in set 2 but not in set 1. To get all these elements, we can use the symmetric difference method. If I write set 1 dot symmetric difference set 2, then it returns those elements. This operation can also be represented using this caret symbol. If the two sets do not contain any common elements, then those two sets are called disjoint sets. Here I have this set 1 with elements 1, 2 and 3 and set 2 with elements 4, 5 and 6. Both the sets do not have any common element between them. If I write set 1 dot is disjoint set 2, then it returns true. These two sets are disjoint. We can also check if a set is subset. If all the elements of set 1 are part of set 2, then set 1 is said to be subset of set 2. I have these elements 1, 2, 3, 4 and 5. Not all the elements of set 1 are available in set 2. So if I perform set 1 is subset of set 2, then it returns false. But if I modify my set 1 with elements only 4 and 5, then both these elements are also part of set 2. Now if I check set 1 is subset of set 2, then it returns true. Similarly, we can also check the superset relationship. Superset is inverse of subset. So in this case, all the elements of set 1 are part of set 2. So if I write set 2 is superset of set 1, that means it's asking if set 2 contains all the elements of set 1, then it returns true. We can also clear all the elements of a set using clear method. Here I have this number set. I can print the number set and it prints the numbers. If I write numbers.clear and then if I try to print this number set, then you can see that it has become an empty set. The clear method has removed all the elements from this numbers set. So these are some of the methods available on the set objects. Sets are very important data structures when we want to avoid duplicates into our data.